All right, it's 1 minute past 11, so I suggest we start. I hope it will work online as well. We'll see. So thanks a lot for coming to this workshop on building renovation, which is organized by the NEBULA project. We have 7 projects lined up today. They will present you their work. They will have to condense in 8 minutes 3 or 4 years project. It will be quite a challenge for them. But let's say it will be a teaser and you can then speak with them at the break. All right, so that's the agenda. We'll just start quickly with an opening. Then we have pitches from the project. We'll have hopefully time for the Q&A and just some final comments. I haven't at all foreseen any speech about why we need renovation, why it's still a challenge, and so on. I will just quickly go through the NEBULA project in case you don't know us. So NEBULA it's a project funded by Horizon Europe. It's a coordination and support action. We are actually supporting the Build for People partnership. I don't know if you attended the Build for People stakeholder forum yesterday. It was very good. So the objective of our project is first to foster the dissemination and adoption of the new European Bauhaus values and principles towards the construction sector, because when we started our project, the new European Bauhaus was something very nebulous, so we wanted to translate it in a bit more understandable term. The second objective is to facilitate access to funding and networking opportunities through the B4P partnership. And last but not least, to set up a network of innovation clusters to enhance collaboration between various types of organizations and foster open innovation. That's what we offer to those clusters and then ecosystems. First, activities and tools related to the new European Bauhaus, various resources that you can find online, for instance, webinars and a handbook. Then open innovation support to clusters. Here it's activities related to first piloting activities with what we call our front-runner clusters, which are based in Spain and France, and then to transfer those good practices to new clusters. And actually we had 10 new clusters joining our network yesterday. And finally, to provide to try to simplify the access to finance by providing guidelines and tools to enable the clusters and the members to better navigate through the different type of financing. That's our map of clusters. Actually, I haven't updated it yet. We have now 10 more clusters that are in yellow, so that have signed the charter. That was yesterday, and more to come. And actually, that's it for me. So what we also try to do in this project is really to foster cooperation between the different projects that have been funded by the Build for People partnership, but also former projects related to renovation. And that's in this framework that we are hosting this workshop today. So I would like to introduce our speakers. So we have, as I said, 7 projects. They are all related to renovation, but from this different perspective. We have tried to group them in a logical order. Let's see if it works out. And we'll start with the EBENTO project. So we'd like to welcome Alejandro Alonso from the Valencia Climate and Energy organization to come here. Please. And Alejandro, I think you picked the most difficult chair in the whole room to join the desk. So if you can use either that one or this one, it's up to you.
Should I stand up or, yeah?
As you want.
Okay, and I use like this, right?
You can use this one.
Okay. Hello everyone, good morning. So, as presented, I'm Alejandro Alonso from Valencia Climate and Energy in Spain, and I will present the project EBENTO, which is focusing fostering the house renovation. So just a quick glance, just to say that we are these 7 countries working together, and we have 4 pilots, and that we are in the middle of this journey of 36 months duration. But let's go directly to the objectives of the project. EBENTO is mainly focused on developing a digital one-stop shop in which we pretend to gather all interested parties in the renovation, both demand and offer, and also the financing part. We focus on citizens as key agents for the renovation because we need them to participate and foster these activities with their demand. And we also want this one-stop shop to act as a decision-making tool for public institutions and energy communities. As mentioned, we also include the financing because one of the barriers for these activities is to access to this financing, and most importantly in the early phases of these projects, and introducing also the use of energy performance contracts in these activities. So if we see it as a scheme, we have like the one-stop shop as a whole, and we have three important modules inside. We start with the simulation module, is in which we can have the models showing how under the different renovation scenarios the dwelling would perform both physically and economically. We also have the monitoring module because we can also monitor the performance of the building in terms of energy comfort and thermal comfort and energy consumption. And these two modules feed the energy performance contract module because this information will give information for the ESCOs and financing entities to detail how the contract is defined. This is a short, quick glance on what the aspects of the platform would include. We have the dynamic map in which you can see the energy performance certificates in the city, also to show the simulation part. We have also the monitoring platform where you can see how your dwelling is performing. And with this, I wanted to show that you can join the platform depending on what's your role. If you are part of the demand or the offer or the financing, you will have different roles to sign up. Because inside you will have this match between the parties, so you can, as a citizen, you can look for different companies, and you as a company, you can you can put all your offer and match with the demand. And also the part of the energy performance contracting definition. And we see it is very innovative and important because we want this platform to act as a logbook where you can find all the necessary information to define your contract, and you can have all it stored and have also the inputs from the simulation and the other modules. But it's important also to say that this is a logbook, but all the legal decisions and the actual contract will be signed out of the platform. So you can have this as a logbook, but you have to do it like legally outside the platform. Coming back to the pilots, we have 4 in total, both in the Mediterranean part, in Valencia, Spain, and Athens in Greece, and 2 more in the north, in Tallinn, Estonia, and Manchester, UK. And if we take a look on the Valencia pilot, we are focusing on monitoring in total 24 dwellings, both before and after the renovation. This community has just finalized with the insulation of their building. There are two twin towers of 17 stories tall, and we're monitoring these 24 volunteer dwellings. It is key that we have engaged them in a proper ways because they are, as I said, they are volunteers, and we also engage the ESCOs and the professionals in the city because it's key to understand how the ecosystem works in each city because they are very, very different in terms of the economic performance, I mean, let's say the market, and the normative. And this is key because we are the organizers of the pilot in Valencia. We are Valencia Clima y Energía. It is a public foundation, part of the city administration. And we have some experience working in European projects related to climate, to energy, in energy poverty, right to energy, energy communities, and also now in renovation. And we always do that in a transparent way. We want to approach the stakeholders and be perceived as a trust entity and transparent, and this is key. Wherever you have these pilots and these volunteers and someone that has to give their participation is key to have this approach. And we also use our proximity offices that are all around the city at the street level. So we form and inform people and professionals about energy and climate and how can they improve their life. And let's include also the renovation wave in this, because in Valencia is still not taking off, and we need a lot, including the financing, but a lot of information. So this was very quick. What are we working on, EBENTO? So thank you very much for your attention. And if you should have any more doubts or questions, just reach us here in person or in the net. And thank you very much again for your attention.
Yeah, thank you so much, Alejandro. So now let's move on to the FORTESIE project, and I invite Vivi Paglaki from European Dynamics to present it.
Thank you. So hello from my side too. First of all, thank you for coordinating this, Karin. You did an amazing job. So I'm here to present FORTESIE. FORTESIE is a project funded by European Union Commission. It's a Horizon project, started 2 years ago and spans a lifetime of 36 months. It has 26 partners from 11 European countries. So the core of FORTESIE are the smart contracts, the renovation packages, and the performance guarantees that follows the previous 2 pillars. And the objectives are the digitalization and automation enablers, the EPC packages, as I said before, the demonstrations that we have, which are a lot. We have 7 different pilots in 6 countries. The new business models that we are creating that will serve the renovation packages as a service and not as a product as it is right now. And also our objective is to boost the renovation wave with performance contracts and with performance guarantees, just to gain the trust of the renovation recipients. So let's dive a bit more in some of them. So regarding EPC packages, we have gathered all the needs of the end users and the target group. So we combined renovation technologies for the specific needs of each pilot, and we combined it with digital technologies that will follow the guarantees. And in FORTESIE, we aim to reduce the energy consumption, to improve the environmental quality, and to reduce the CO2 emissions. And then we have the digitalization components of FORTESIE. So we first measure in the digital tools, get the measurements, and we analyze them. We analyze them using the behavioral models and the recommendation engine. And then the technology improvements are guaranteed through a trusted smart contract in blockchain. And also all these data are presented to the users through a mobile app, which are user-friendly. It's user-friendly, and inform the user about what actually are these information and how they will benefit from them and how they can get involved with this information. So we have divided the pilots into 2 different categories. We have public buildings. We have 4 public buildings, one public pool in Poland, 1 school in Latvia, 1 public building, the Ministry of Digital Governance in Greece, and 1 museum in Greece. All buildings are old, meaning that all buildings need so much energy for heating and cooling, and also means that they are built with outdated material and built with energy inefficiency. So all the indoor quality is poor, and all the occupants there needs this renovation not only to save the energy, but also to improve the quality of the well-being of the people there. Then we have the households. We have different households in Spain, France, and Portugal. These buildings are also old. with outdated material. And the necessity there is to build trust to people to do the renovation because they don't know the benefit that they will get through it. So lessons learned, first of all. We found out that using the behavioral model and also the mobile app for gauging the user is not enough. So we found out that if we introduce the comfort price, as we say, is a concept that translates into value the price that someone should pay to heat their home. For example, if someone wants to heat their home, they will know exactly how much they should pay in order to achieve the wanted and the desired temperature. So they will make a decision. Maybe they will make the decision to put another layer of cloth, or maybe to renovate the house better so they can decrease the comfort price to a better value. And then the integration complexity. We found out that each building, its owner adopts different measurements, different measurement systems and different sensors with different database. So we needed to find a way to translate it and to transport it, this data, to a common database. So we created a common data model at these digital tools called SDC's Agent and SCH that will transport the data from every platform to ours. So it can be homogenized and it can be valuable. Regarding challenges, building collaborative business models was a tough job, needed a lot of co-creations between the diverse stakeholders and their diverse needs, and to make them scalable and replicable was really tough for us. And also the renovation complexity, because we have very different stakeholders in each renovation. So this caused delays, and this also make us believe that building a marketplace to streamline this collaboration would reduce the delays there. Then we have a lot of bureaucratic delays. If not all of our pilots, like most of them, had bureaucratic delays or public authority delays due to, I don't know, really, I don't know. So they slow down their renovations and they make the renovation more costly. And then the one-stop shop marketplace, we also have one as the EBENTO. So the problem there is to create a marketplace that is as informative for the non-experts as possible, and also to gather and create a big and wide network of stakeholders there. So we need to attract all the local players in order for the end user, for the building owner, to get in this platform and find what he needs. So here are two QR codes. The one links to an animated video for the FORTESIE project and describes what FORTESIE is and what the pilots are. And also the second one is the marketplace. So please, I don't know how many people are here, 40, more or less. Can I have 40 new registrations until next week in our marketplace? It will be great. It will be a great outcome of today's session. So that's it from my side. Please stay connected, follow us in all our social media, and find out what we're going to do next. Yeah. Are you registering now? You're welcome. Thank you.
Thank you so much, Vivi. And now we have George Janiakis from, how do you pronounce Q Technologies? who will present, sorry, CHRONICLE.
Thank you so much, Karin, for the introduction and for moderating this session. I'm George Giannakis from Q Technologies, an SME company located in Athens. And I'm here today representing CHRONICLE, a Horizon Europe EU-funded project, which actually aims to, at first, develop and deliver user-friendly digital tools that actually provide valuable information to the different key stakeholders that are involved in the whole process of renovation and building performance assessment. Sorry. Next, to develop and deliver a holistic energy performance framework, where actually all the data that are required to assess a building are gathered. And for delivery of this holistic performance evaluation framework, we are following the BEAM standard because the static information that we're collecting is based on BEAM. And apart from that, we are also trying to adopt standard solutions for the IoT data. We will talk about them later on. And last but not least, to validate all the CHRONICLE solution and results, and its impact assessment, perform all the impact assessment in real world settings. So conceptually, CHRONICLE aims to deliver a comprehensive toolkit that contributes significantly to the building performance digitalization and tries to the maximum possible implement the dynamic logbooks for future value-driven services. It brings together. Sorry for the resolution of this image. I don't know what happened in my PC. It was working perfectly. I'm trying to explain what we should see here. Actually, CHRONICLE tries to bring together all the key stakeholders involved on the whole process of a renovation project. Actually, not only the renovation, we are focusing on the design phase, the operation phase, but also the build phase. So actually, CHRONICLE brings together the key stakeholders involved in the process, like architects, engineers, facility managers, investors, public authorities, but at the heart of the solution, we do have the occupants, because the service that we are developing is to provide valuable information that is understandable by the occupant. A key enabler for the overall solution is the Building Holistic Dynamic Performance Framework, which is actually a collection of calculation engines, calculators, that go beyond energy metrics. We do have calculators for comfort KPIs, indoor air quality, well-being, social, financial, and sustainable KPIs. But to calculate those KPIs, we do require significant data from different sources. And actually, these data are mostly generated by the Digital Twin Framework, where actually the Digital Twin Framework is an integration of two different types of digital twins, the physics-based digital twin and the data-driven digital twin. The first one is the one that performs all the physics-based simulations and generates results that are meaningful and make sense to be used for the calculation of KPIs, whereas the data-driven approach is mostly about creating, based on measured sensed data, virtual replicas of all the energy-hungry systems of the building, but also try to combine those those two digital twins to achieve what we call reducing the gap between simulated and measured performance. Backbone of this digital twin is the common data environment. Actually, you can realize that to make those data available in a machine-readable way and in a common way, you do require a very, very robust middleware. A middleware that, based on the needs of each of the digital twins, provides those data. And we are talking about a middleware that fuses BIM and IoT data to achieve what we call semantic interoperability. So, fast forward 2 years, and CHRONICLE has moved from the concept to actual implementation. And the image that we see on the left, that is the conceptual architecture, has been changed to what we see here. This is a very high-level architecture of the overall solution that we are developing. And here I cherry-picked some of the user interfaces of the CHRONICLE solution. The first is the digital building logbook, which is actually different reports that are being collected, the records of the building to be communicated as a picture of the building current status and activities that have been planned. The CROView REN, which is actually an application that's been developed to design different renovation options and based on the different targets that the user set, evaluate those renovation options. Actually, here we do realize the first complexity that we have in our solution. When someone creates a renovation option, all this information is forwarded to the digital twin, where the assessment of the renovation option is taking place, and the results that are generated are being hosted in the common data environment that I presented earlier, and being visualized through this user interface. Apart from that, the CROView REN is an application that generates the building renovation passport for the renovation option that was selected by the user. Sorry. Yes. And last but not least, the CROView FM. It's an application that is being developed for facility managers. Some of the functionalities that it offers is the BIM visualization, the information that has been collected through CDE, but also informative information for specific devices, and what we managed to deliver not only by measurements, but also trained models, machine learning trained models that forecast the performance of the building. Concluding this presentation, I would like to highlight two key challenges that we faced so far. The first is related to how we collect the data that are required to perform physics-based building energy performance simulations. Actually, it comes as no surprise that we do have four main categories of building: the static data, dynamic data, weather data, and other simulation parameters, which required domain expertise. And although it's quite easy to find a way to represent weather data and other simulation parameters and collect relevant data, it's quite challenging to collect static and dynamic data. It's quite common that at the time that is required to generate a building physics-based simulation model takes more time than what was originally planned in the time frame of the project. So and apart from that, another key challenge with regards to dynamic data is that it's quite common that the simulation engines use deterministic models which means that we do have predefined schedules that we use as input to simulate the occupant actions upon systems. And we do not learn from sensors how these systems actually operate. And this is the main reason why we have this gap between measured and simulated performance. So to address this challenge, within CHRONICLE, we have automated the process of generating the static data by developing an IFC to input data file mapping of the data. So we do make use of data that are available through BIM to generate the static information that is required for simulation engines. And with regards to the dynamic data, what we do is to use OBXML. It's the occupant behavior XML result of a project that actually presents in a standardized way, how the machine learning results and models that actually forecast and generate the schedules about how the systems operate should be represented so as to achieve a co-simulation between the OBXML and the static data, and this way reduce the gap that I mentioned before. I'm very sorry, this is the last slide that I have. It's the second and last challenge, main challenge that we faced. And it's something that was also mentioned by Paraskevi previously. It's about the need for a common data model. You realize that making all this process and integration of different tools possible, you do need somehow to develop and deliver a common data model so as to make the fusion between static data and dynamic data. And with regards to static data, we talk too much about the BIM, but if you do have experience with BIM modeling, it's not that easy. And the result from a BIM modeler to the other could be very, very different. This means that we need somehow to formalize the way the data regarding BIM are being generated, collected, and validated. And to do that within CHRONICLE, actually, we have developed some guidelines that showcase to the BIM modeler what the steps needs to be followed to export from BIM authoring tools open BIM data like IFC that fulfill the requirements of the project, but also validate. We also developed an information delivery specification. It's a terminology well known to BIM modelers and the BIM audience to formalize the way the data are being validated, which means that it semantically explains how the open BIM data exported from the BIM are being checked and validated to perform those actions of validation and then inform the BIM modeler about mistakes that made during the BIM creation process. And with regards to the common data model, actually, just to mention that we inspired from two ontologies. It's the brick and the bot ontology, the brick for the IoT part, and the bot ontology for the static data part, the BIM data part. And that was me. Sorry for taking a bit longer. Thank you.
Thank you, George, for this very detailed presentation. All right, then let's move to the REHOUSE project, which will be presented by Javier from Cartif.
Okay, hello, good morning. My name is Javier, and I'm coming here from Cartif Technical Center from Spain, and I'm here representing the REHOUSE project. I'm the technical project coordinator. And the name of this presentation, as you can see, is the holistic renovation packages, but considering the circular approach. So, firstly, I would like to give you a brief introduction for REHOUSE. So, the name of the project is a renovation package for improving the EU buildings efficiency, maximizing the renewable energy generation and the cost effectiveness. The main objective of our project is to design and develop 8 renovation packages. These renovation packages, the objective is to have them validated at TRL 7. This means that we will deploy them in 4 demo sites, and we will be validating them in operational stage. And the main objective is at the end to increase the current very low renovation rates that we have in Europe for the building stock, and to increase them and improve the energy efficiency of our buildings. Here you can see some of the key objectives that we have in the project. The first one is related with the social aspects of the project, and is to consider this people-centric approach in our demo sites. For this, we have created social task forces in each of our demo sites in order to obtain these needs and requirements from the end users. Also, secondly, we have as objective to increase the current TRL levels of our renovation package from 4.5 to TRL 6. This is done in the manufacturing, let's say, facilities of our RPs. And also, we are applying BIM-based workflows, and we are also considering the IPD methodology. This means that we are considering all the stages of the renovation of a building, from design, construction, operational stages mainly. Also, as I mentioned before, we will be validating our RPs in 4 demo sites. So we have 1 demo site in Greece, 1 in Hungary, 1 in France, and 1 in Italy, in which we will be deploying our 8 renovation packages in order to validate them at TRL 7. This means that we will be validating our renovation package in operational stage. Also very important for us is the definition of business cases and business models for each of our renovation packages in order to define the pathway to the market in how we will achieve this TRL 9 at the end of the project. Also, we are thinking about how to escalate and replicate all our renovation packages, because we want also to have them potentially be replicable in other buildings after the project. And also we are creating standardization guidelines. And also very important for us is, like this one of event, like these events, is to work on these activities related with dissemination and communication. I would like to give you a quick overview before entering in more detail on our renovation packages. So as you can see here in REHOUSE, we are working with 8 renovation packages. We can group them into 3 main groups. The first group is the one related with that is more related with the active elements. That is the one composed by RP1 and RP4. That is the multi-source heat pump and the centralized solid heating and cooling kit. Then we have other group that is more related with facade systems that are RP2, 3, 5, and 6. Then I will be entering more detail and presenting you more details about this. It's only to give you firstly a quick overview. And then we have other 2 renovation packages that these are more, let's say, small ones, which can be integrated in the facade system. So these are the one is more related with an insulation system, and the other is the intelligent building system. So this can be applied to the RPs that are more related with the facades. With these RPs, we can cover from limited renovations to deep renovations, as you can see here, and each of them has different principles that I will be presenting you in more detail in the next slides. Here, I would like to present you our 8 renovation package by giving you some brief details of each of them. The first one, the RP1, is the multi-source heat pump. This heat pump uses different kinds of heat sources. We are using, for example, solar energy, but also geothermal and air. Here is very important the definition of the control strategies in order to decide which heat source to use each time. The main function of this is to cover the heating and cooling demand and also the domestic heat water of the building. It has a very high performance compared to other conventional heat pump systems, and it uses refrigerant that it has a very low environmental impact. Then RP2, this is a multi-facade system. It's made of sustainable materials. Mainly we use recycled aluminum and glass. We apply here a prefabricated concept in order to reduce the time and cost during the construction. Also, it can be adapted to different type of buildings, so it has an adaptable design, and it integrates different components. We can decide which components we want to apply to the building depending on the needs of the specific building. And it also integrates a complete full monitoring system in order to control everything. So it integrates sensors and actuators. RP3, this is also a multifunctional facade system. This combines also different components, for example, insulation, PV panels, batteries. So again, you can, depending on the needs of the building, we can adapt this RP. It's also, we can also apply this to different type of buildings. It's also prefabricated. All of our RPs are prefabricated in order to reduce the time and cost during the construction. And the main functionality is to cover also the heating and cooling demand of the building, but also to cover the ventilation needs and the energy generation if we integrate the PV systems. The fourth one is the heating and cooling kit. This one is based on a conventional reversible heat pump system, which integrates also a PCM, integrated thermal energy storage, stratified storage. The energy for the heat pump is mainly coming from the VIPV system that should be also integrated in the building. The main function to cover the heating and cooling demand, but from a centralized way. It's also made it's composed of recycled and biosourced materials, so it means that we have a very high replicability potential, and it also integrates an efficient management system in order to coordinate all the systems. Okay. Then the RP5, this is also a multifunctional facade system. It's based mainly on an insulation and BIPV system. It's also integrating a sound absorption panels in order to reduce the noise inside the building. It's also a modular in order to be applicable to other type of buildings. And the main objective of this is to improve not only the energy efficiency of the building, if not also the aesthetics. The RP6, this is also a passive or a multifunctional facade system. This is constructed based on an already existing commercial system that is called a panoblock, but adding some additional elements such as the ventilation and the second life PV panels. And it's also following the same principles, that is prefabricated and it's made of sustainable materials. And then the last two ones, I'm sorry because I don't know why we are not okay now. These are the last two ones that, as I mentioned before, this can be integrated in the RPs that are for the facade systems, and these are the active cellulose isolation that is made of 100% of natural composition. It's mainly made from wood and agricultural waste. So in some way we are using something that is waste and we are converting this in something valuable, and that is using the buildings as isolation material. And then we have, lastly, this is the last one, the RP8, that is the smart, the intelligent window system that with this, if we add this window to a building, we can reduce the energy consumption of the building by 50%. Also, it integrates different control and actuators in order to optimize the working conditions of the system, and it's also made from sustainable materials. Here you can see an overview of our 4 demo sites in which we will be deploying our 8 renovation packages. We have one in France that is a residential building block in which we will be applying the panoblock solution. Then we have one in Italy in which we will be applying the heating and cooling kit, and also we will be applying a multi-purpose facade. Then we have other 2 buildings that are residential buildings for the students, one in Greece and one in Hungary, in which we will be applying also some solutions related with facade systems and also others related with the active systems. And finally, and this is my last slide, and it's only to summarize the circular principles that we are considering in REHOUSE. Most of our renovation packages are made of recyclable and bio-based materials in order to increase this circularity potential of our renovation packages. Also, we are considering this modular design and prefabrication concept in order to reduce the time and cost during the construction, but also we are reducing in this way the waste that we produce during the construction. And also, we designed this our renovation package by thinking in the end of life, in order how we will deconstruct this RPs in order to be reused in other, for example, buildings or for other purposes. We are thinking also, we are considering this recycling and reuse, and this means that we are using recycling materials, and we are using some reuse. We are reusing some components, such as, for example, some PV panels. Also, we are converting some waste. For example, we are in RP7, we are converting something that is waste, that is the wood waste and agricultural waste, in something that is valuable for isolating the buildings. And also, very important for us is the energy efficiency and renewable energy integration. With this, we are reducing the energy consumption of the buildings, and also we are reducing the CO2 emissions. And in this way, we are also considering this circular approach in our RPs. And that's all from my side. So in case you want to know more about REHOUSE, you have here the QR, and you have here also the logos from all the consortium. And that's all from my side. So many thanks.
We'll have a Q&A session at the end, actually, because otherwise we'll get completely sidetracked. Thank you. But remember your question then. All right, thanks a lot, Javier. Then José Luis from the University Politécnica de Valencia will now present the INPERSO project.
Okay, thank you. Well, I am José Luis from the Polytechnical of Valencia. I am the technical coordinator of INPERSO. I think we have similar solutions for the same problems, no? And I have to explain less from the project and more for the problems that we have, no? And, well, INPERSO is a holistic deep renovation program designed to address the challenges of digitalization, fragmentation, quality, efficiency, and speed throughout the building's life cycle, from project design to end of life. To achieve this, the project involves the entire renovation workflow in all processes, considering three phases: pre, during, and post-retrofit. The basic aim focuses on a human-centered approach through the development of low-carbon renovation models. We use digital BIM-based tools, as the other projects, to have continuous tracking of energy performance, user comfort, and a dynamic database at the stakeholders' disposal. Last but not least, we are testing several new technologies together in our pilots and integrating them in a retrofit kit. We have three demonstration cases in Valencia, in the city center, where we are specifically testing the retrofit kit synergies, installing a combination of these of all technologies in 8 flats, and with the added problem of having a building partially listed. The second is in Belp, in a typical Dutch landscape, with a complex of 2 old monasteries converted into social lodgings. And the key here is to deal with the high level of protection of the buildings, forcing solutions to be fully integrated. The third is a social housing block in Varivoula Voliagmeni, near Athens in Greece, and we are mainly comparing the industrialized process with a conventional retrofit, maximizing indoor comfort and energy performance. Well, we go directly to good practices. We have 2 things to say. We think it's very important having a technical partner to support public administration responsible of the projects. These teams have not many skills, no, in this type of projects, and they need some help. The other one is we think it's a good practice to invest many time and effort in the first phase of the project to understand which are the synergies between the different technologies and how they can be integrated in the demo cases. This is something very important for us. Regarding the lessons learned, we have three, but we have more, but we have to summarize. For example, pay particular attention to the pilot's development risks. It has been said today, budget, licenses, tenders, political changes. There are many problems that have to be solved. Secondly, the stakeholders' engagement. We think it's very important to implement effective and flexible incentive systems to avoid refusing or dropping out, especially from end users or tenders. And, well, we find great difficulty in maximizing synergies between different technologies which have been developed in different companies, no? Put them together. No, it's okay, it's automatic. Well, regarding the challenges, we have two types of challenges, complete workflow analytic approach with the different phases. We find very difficult to fit the jigsaw puzzle of coordinating technologies and pilots into the right timing. No, it's very difficult for us. And another problem is to identify, classify, and select KPIs valid for all processes and systems in the impact assessment, because they are very diverse. No? There are many differences between the different types. Now, the other challenge is we are using industrialized solutions for heritage buildings in our project. Industrialization of the built environment requires personalization and adaptability. We are using standardized and precise systems that must be applied to handcrafted buildings, and this is very difficult. Of course, compatibility between heritage buildings and prefabricated systems requires having common criteria. But these common criteria in heritage are not universal. We must interpret and adapt to multiple factors, type of buildings, state of conservation, historical, architectural, economic, social, and symbolic values. Of course, some buildings or parts of historic buildings or sites have many opportunities, but not everything is possible in them. It is very important to recognize where and which are the limits. No, I think it's a very important issue in heritage building. Well, compared to traditional processes, we have to know how to develop high quality and cost-effective industrialized solutions. Well, we have to be cost-effective, especially. Well, one method or one possibility is use reversible interventions, no? Reversibility. This is key to convince certain stakeholders, for example, administrations, owners, and the citizens in general, of the need to automate these processes and systems because they are more cost-effective. Well, I think this is all from my side. You have all the information of INPERSO project and all the partners in this last slide. We think it was important to focus on the challenges and the lessons learned and the things that we are asked for, and this was our aim. Okay, thank you very much.
Thanks, José, for this perfectly timed presentation. And now I invite Matteo from RINA to present the SMARTeeSTORY project.
Thank you. Good morning, everybody. First of all, my name is Matteo Porta. I'm here representing RINA Consulting and to introduce you the SMARTeeSTORY project. Thank you, Karina, for your coordination of the workshop, first of all. And yeah, we are the coordinator. I'm representing the team from RINA Consulting, an Italian large company. And I'm representing the team of coordination. And yeah, it's a pleasure for me to be here to present this project together with the others with which we are sharing challenges, sharing technologies, sharing approaches, and also try to find new solutions and new approaches to the difficulties that we are encountering in this type of project. The SMARTeeSTORY project, it's at 15 months lasted from the starting of the project, and it will last until 2027. 13 partners are participating into this project, and it's focused on technological solution for historical buildings, so quite closer to what has been presented before. And I recognize in what has been presented some of the challenges that we are facing in this project. As you can see here, we have I summarized the three main objectives. The main objective and scope of the SMARTeeSTORY is to create a building automation and control system for monitoring and optimization of historical non-residential building. Because here the focus is to try to create more efficiency in historical buildings when renovation, for example, of the envelope, but also of the technical building system is not always an option, because buildings are, of course, protected because they are historical. And so the solution is basically based on digitalization. And we started from using the SRI methodology. So we are including the 9 domains of the SRI methodologies, incorporating also the human aspects, so the point of view of the users, of the end users of the buildings and of the technologies. And the SMARTeeSTORY systems, so it is enabling the possibility, to include also the users' behaviors and the user point of view, because it's developing building user archetypes that are via specifically developed algorithms that can detect the people that is living and using the buildings, and in order to inform the control logics and the automation systems accordingly. And to do this, we are developing an interoperable and cyber-secure by design software and hardware solution, and basically including several functionalities and to optimize the operation of the technical building systems, and of course changing the conditions of the control logics according to the demands and the end user behavior. So this is the main architecture, the concept. As you can see, the core of the system is a cloud, an IoT cloud platform. We are developing this cloud platform so as a technology. So the project is very technical, because this is the core. And on the right hand side of this picture, you can find the 4 main services that will be enabled by this web platform, that are monitoring, analysis and prediction, optimization and control, and digital twin services. So the idea is to enhance the performance of the building through digitalization and optimized control of the technical building systems. And to do this, we are, of course, the IoT platform, the cloud platform, is connected to the field via several hardware devices, like edge computer or server like BMSs that are directly connected to the technical devices and the sensors and the actuators that are actuating the control signals that are coming from the cloud platform. And this is done in coordination with and connection with the end users that are living the offices and the buildings in this case. 2 minutes, okay. So this is basically the methodologies. We are mainly three phases, the mapping phase, the modeling and the software development phase, and the demonstration phase, but this is quite common to all the European projects. We have 3 pilots, one in Riga, one in the Netherlands, in Delft, and one in Spain, in Granada. The Faculty of Architecture, you can see here in the picture a summary of the initial status from an SRI point of view. So initially we have calculated the SRI level in the 3 demonstrators. You can see here 21 class F for in the Netherlands for the Faculty of Architecture, 12% in class F for the High Court of Justice in Granada, and 12% class F again in Riga. And then according to our energy conservation measures, so the digitalization of the system, we are achieving an enhancement of this SRI. And so then this slide is about the good practices and lesson learned. So the first, and so on the left side you can see the challenges that we are facing. So one main challenge I would like to transmit to you is to try that we are trying to match the SRI methodology, so the SRI calculation, so a method that is providing the smart readiness level of a building with the standard KPIs estimation in terms of energy, in terms of comfort, and in terms of environmental impact. So this is not a straightforward connection between the SRI methodology and the standard comfort calculation. And so we are trying to understand how the improvement of the SRI then could be reflected in an effective improvement of this standard KPI. So basically the comfort inside the buildings, and of course the economic viability of the intervention. Then another challenge that I would like to mention is the time needed to diagnose and to consider for the technical inspections and the pre-intervention monitoring campaign, because this is a very lot of time is required to set up everything. And so this is something that even for the fact that the building are historical building, so have many constraints, this should be taken into account. And then relate also to the previous comment from the other project, data availability for modeling activities is of course very important, because when we discuss about data-driven models or physics-based model that we are using for the optimized control logic, of course the need of data is huge. And sometimes buildings or facility managers or whatever they are not ready to provide this big amount of data. So the problem of data availability is very, very important. And of course, last but not least, has been mentioned for other projects, the time spent for the public tendering processes, the procedures and authorization, it's quite an important challenge. And of course, we need to take into account that there is the need of a lot of time for the tendering procedure, even when we are talking about historical buildings. That's it from my side. Thank you very much. And this is, if you have, of course, any comments or questions, this is my address.
Thanks, Matteo. And the last presentation before the Q&A session will be for the MULTICARE project, which will be presented by Lukasz from ISM.
Okay, thank you all for being here. I won't be too long as we are approaching the end of this part. So I am presenting MULTICARE project, which is have many similarities to what was already presented, but here we are focusing more on the preventing natural disasters and how to prepare a building to become more resilient to those things. We are already almost 1 year, so we are not so advanced still. We are more in the phase of the theoretical frameworks building than real implementing of our solutions. So I will just briefly present what we are now working on. So the first part and the main objective is to develop plug-and-play hardware, let's say. So it contains of the structure plus facade, and what is our main challenge now is to develop the connector and how to make it very commonly being used to different materials. So, for example, how to connect timber to timber or timber to structure. And this is a challenge how to provide and construct and in a factory a single screw that will connect both types of these materials, so timber structure and timber to timber. The next objective and our challenge is to connect different hazards into one response system, because now they are more, let's say, independent to each other. And the idea of the MULTICARE is to bring together all those natural disasters together and to combine the response in the buildings, taking into consideration each of them. So here we are focusing on the earthquakes, floods, and the heat waves. Then to support this hardware, so these plug-and-play facades, we also will develop several digital tools. Here also a bit different to what was already presented, not focusing on the energy performance, but on this real-time monitoring and real-time warning to prevent the impact of these natural disasters. So, for example, how to connect the facades and digital tools with, for example, weather stations to have this signal a lot time before the exact flood or earthquakes will come to this building. And for example, in terms of the earthquakes, what is very nice, and I want to share with you, that we are testing our facades in the special equipment for the earthquakes performance, and we are happy that, for example, our facades take the impact of the earthquakes, preventing having cracks on the main building structure. So this is not only the warning, but also the physics of the earthquakes. The impact will be more focused on the facade, our plug-and-play, than on the main construction of the building. So yeah, so I already said about this real-time monitoring. So it is, as I said, to predict the upcoming natural disasters, and of course made the response. But another aspect of having these digital sensors being applied into the facade is to also monitor how the building behave after such kind of disasters, to also have an opportunity to, for example, change the envelope of the building. I don't know, for example, change the connectors, and it could be done by receiving the data from these sensors, and then in the laboratory we can use different kind of concrete, different kind of timber-based materials to and test them in the laboratory to make this prevention from the earthquakes, for example, better, and then apply it to the building. And to do that, we have 3 buildings that will be that are our pilot sites, and those buildings will really have those plug-and-play facades being constructed in the factory, and they will be really applied in that building. So currently we're using sensors to gather the data before those facades will be applied in the building, and later on, of course, we will have data collected after the facade will be installed, so we can then compare how different aspects of the building environment will change. And the last part from MULTICARE is that, of course, as every one of us, we need to take into consideration not only the technology itself, but also the community engagement. And here is other aspect and challenge, also similar to others, how to attract people to really start interesting in such such technologies. And for example, when we were on our pilot site, there were a huge problem with people how to tell them that, for example, the facades will not hide the sun, so the amount of the sun will be enough in their buildings, and it's really hard to show them on in a mathematician way the numbers that the amount of the sun during the day will stay the same. So these are the things that they are considering as something hard to imagine for them. Okay, thank you very much for your attention. Thank you, Karim.
Thanks a lot, and thanks again to all our speakers for presenting their project in such a short time, and also for sharing their experience, lessons learned, good practices. That was really interesting. We still have some time for Q&A session. I will just have a couple of slides at the end, but I think we have more than 10 minutes for questions. And Jürgen, you had a question, I think, for INPERSO.
You mentioned this bio-based materials for insulation. What is the lambda value, the thermal conductivity of this? What do you reach for this? And the other question is, there was one case study with a historic facade. How will you deal with that?
Okay, for the first question, I'm not directly involved in designing and developing this RP, so that we have other colleagues in the project. So maybe if you have a specific, or if you want to have specific details about this, maybe you can contact me. I can forward this information to my other colleagues in the project. That maybe they can give you more accurate answers for this. Yes. But I cannot give you right now the specific numbers of the U values on this because I don't have it in my mind. I don't know at this moment. I know that we are decreasing a lot and we are improving the energy efficiency of the buildings, but I don't know the specific details. And for the other question about the historical building that we have in Hungary, in Budapest, this is an old building, and at the beginning of the building, when we were working in the proposal, we were checking this historical value of the building. This was checked with the legal authorities there, and they gave us the okay to proceed with the deployment of this solution and the integration in the building. So although it's historical, we can in some way apply the new facade on the old facade. So we have the green light from the local authorities to do this. So I don't know exactly, yes, how this was done, but we have the green light. Yeah.
Thank you. Thank you very much. May I ask a question to Vukash? You presented us this facade system, and you said that this will be resilient. It will enhance the resilience of the building to earthquakes. So that I assume that it is a load-bearing system, and I think it will be really crucial to connect the building with the existing building with the facade system, I think.
This is why I said this, it's one of the challenges to design these screws for the connection between the already existing facade and our second skin layer. And it's still being under development in the laboratories, and hopefully, I think not hopefully, but we are sure that we will be able to develop those screws and those connectors, as I said, timber-based, timber, and timber to concrete.
Thank you very much.
Hi, thank you for other presenters. It was very interesting to follow with what Lucas said. I would like to ask about the TRL, target TRL for this project, and how you are thinking about validating your solution. I mean, validate with earthquakes and floods.
Yeah, so first of all, we will test this in the lab. So with our equipment, and it's like we first build two floors structure of the building. Then we attach our solution, and as colleagues said, then we perform simulation of an earthquake. So that is a lab possibility to test the solution. As you said, in natural environment, in real life, it's hard to test this, and I hope we won't test it.
I have a question. Yeah. Yes. So I'm Mia Alajosla from VTT Finland. Thank you for the presenters. Very good to see how many ideas and solutions we have to really promote the renovation wave. But I have questions for the project that developed the one-stop shop systems or tools. Who will maintain the system after the project? Do you have a company for that?
Thank you for the question. This is funny because I met my colleague from FORTESIE project, and we were chatting yesterday about this. And this is one of the common barriers about this kind of products, because we developed this in the scope of an European project in which you have fundings and you have these companies developing this, but you have to sell this idea to someone to keep working on this. If I speak about my ecosystem, in the Valencia Clima y Energía Foundation, we have the offices in which we can use these one-stop shops, but we also have from the project to sell myself, let's say, the idea. So the city hall can buy it and hire someone to maintain it. But for sure, you need to sell the idea. If not, the project ends and it has no one to use it. And of course, it is a product, a digital product, but it needs of maintenance. It needs to be used and enhanced by using it, because during a project you are still in the alpha phase. So for sure, it is a very good question. Maybe you want to add? Thank you for the question.
So from my side, from the perspective of an ICT company who will create this marketplace, and our focus is to maintain it and to make it bigger so we can take another project, another EU project, and make something else out of it and create some value out of it. So as an ICT company, we are very intrigued to keep this marketplace and to bring all the renovation stakeholders there.
Maybe I can add to that. Or maybe I should say this privately, but I have my study mate has a company who is providing this one-stop shop service. Maybe I'll connect you with him.
Hello, also thank you for the presentations. Michael Polter from Technical University in Dresden. I have a question to Matteo from the SMARTeeSTORY project. Okay. First I ask my question. A big challenge in for digital twins is always the handling of dynamic data. And so my question is, how do you integrate the dynamic data into a digital twin? Do you use somehow interconnected data structures, or maybe connect IFC to time series from databases, so that you, for example, also could, or the question also, do you also can use the data later from the past to make some analytics and comparisons from past performance to current performance?
Give you some time to think for the way.
Thank you for your question. First of all, we are using data basically to forecast the behavior of the buildings and for the weather forecast. So we have two types of data coming from outside that are connected via, for example, API to the main platform, and are forecaster weather data. For the data that are coming from the usage of the building, we are using data-driven models. So basically machine learning techniques that are used and trained with physical-based models. So in this moment during the project, we are creating physics-based model based on the data that we have available. And this is physics-based model are used for the diagnosis, for defining the baseline condition, so the starting point, and also for train the control logics, and also to calibrate and validate the machine learning data-driven models that we will use to forecast some parameters that will be used for the control logics, the optimized control logics. I don't know if I answered to your...
One-time forecast, or do you continuously update this model to, let's say, forecast?
No, it's a continuous forecast, because the control logic are based on MPC, model predictive control. And we need to forecast the behavior of the buildings in 24 hours time horizon in advance. So we need to update all the measurements every 15 minutes, basically, to 5 to 15 minutes. I hope to answer your question.
Have time for final questions? No? All right, then that's all good. Charlotte, you can come here, actually. Maybe you can present this one, or you can keep it. Yes. Keep your name.
Thank you. Yes, my name is Charlotte Schliger. I'm from Steinbeiß Europazentrum. So this is now a surprise for me because it was not foreseen, but I'm happy to talk a little bit about the network of building renovation projects. We have initiated that from the REHOUSE project beginning of this year, because we thought we should use the synergies, and we have seen today a lot of synergies in the projects, that we should use the synergies of the projects in terms of approaches, in the terms of stakeholders, in the terms of yes, how to reach out and how to collaborate with each other. So we have seen the different approaches, one more focusing on digitalization, one focusing more on cultural heritage, on specific solutions. So this is the idea that we, at the moment, we are more an internal working group. We share experience, we invite each other for joint activities, also such like this one. And, but of course, it's also about continuing in a next level, besides dissemination communication, to go also for exploitation and replication. So because we've got also, you've seen the different demo sites who are acting as role models. Of course, this could be also one angle to continue. And we've got this huge pool of expertise. So once we need a speaker for a specific topic, we will surely have this in this group. And yes, I already mentioned this, the network of synergies. Yes, of course, we would like to reach a wider audience by this. So that really after the project is not after the project, but the beginning of a next approach, the beginning of next activities. So therefore, we're invited to follow us. So we'll see how we will increase also our activities into a next level, maybe institutionalize this network, but this is now the next step we have to come. Thank you.
Thanks, Charlotte, and thanks again for initiating all this. That's my final slide before I release you to lunch. Just wanted to mention that we'll have a clustering event that we co-organize with CINEA on the 19th of November, that we are very happy that we will bring together the 30 projects that have been funded under the B4P partnership. And again, I'm sure there will be very nice synergies and discussion. And also a final announcement about our final event, which will take place in 6 months, so still some time ahead of us, but please save the date in your agenda. And again, we will try to bring together EU-funded projects, especially from the B4P partnership. And yeah, that's it. Thanks a lot for attending these workshops. Thanks a lot to the online audience as well. Well, I invite you to join us at the B4P booth in case you have any questions you would like to ask about the project or the partnership. And I wish you a bon appétit.